All right, so we are in our pseudo AP Calculus BC class. I'm officially calling this an AP Calculus BC class because you guys are now doing the strict regimen of the hard schedule. So I'm not using the word pseudo anymore. Today's date is Monday, March 9th, 2020. Yeah, so we're talking about lesson 2-4, the derivative of parametric functions, which is a lot easier than the derivative of polar functions. So I consider this to be the easier of the two lessons, but the way that I've structured the notes, they might seem like they're hard. So I hope that's not the case. So the derivative, let's take that, right? So the whole problem is, how do we find the derivative? Technically speaking, we were finding dy dx whenever we were taking the derivative before, so let's kind of find the derivative, right? So let's take the derivative with respect to t. So I'm saying dx dt. Let's find dy dt. Who couldn't do that? Nice, easy functions. T squared, you bring the 2 down in front, blah, blah, blah. What does this turn into with a quiet raised hand? Okay, Fiona. 2t, there it is, thank you. Ooh, let's try a slightly harder one, but you guys should definitely know these. T to the power 4, derivative, go. Eva. 4t to the third. Everyone write it down? Getting used to taking the derivative again.
You've been doing this.
So those are derivatives. Unfortunately, they're not helpful. Because the thing that's helpful is knowing where the slope is. Like when I had dy dx, the cool thing about him is if I plug in, I don't know, x is equal to 3, I can tell exactly what the slope is at that line. Well, if I plug, I don't know, x is equal to 3 now, where do I plug in x is equal to 3? I don't know what the slope is. There's very little information that's happening here. I can tell the speed that the x and the y is changing with respect to time or whatever t is, but it's not helpful. So we have to start again. But you can take derivatives, so that's good for D, right? We have to find some way of getting dy dx. That's our goal. How do we get dy dx? Well, we could convert to Cartesian, and we can for this equation, so let's try it. So if I have x is equal to t squared and y is equal to t to the power 4, let's convert. And I'll give you the general setup because I know that we struggle a little bit with conversions. I can say that x is still t squared. I haven't changed anything. But I'm going to call y something else. I'm going to say y is equal to t squared squared. Does anyone see a way to substitute one for the other?
Y is equal to x.
Say it louder, Arrow.
Y is equal to x squared.
Yep, that's correct. How'd you get it?
If you substitute in the t squared because x is equal to t squared.
Yeah, if that t squared and those t squared, they're the same thing, so t squared is x. This t squared is also x. Okay, so we've converted now. Well, Arrow has converted now. So this has now been converted. So therefore, our new equation is y is equal to x squared. We have converted this parametric function that was given in x and t, y and t, into just y and x. That's Cartesian, the thing that we're used to. And hey, look, that's just a nice little parabola. It's a smiley face. Goes through the origin. Everyone can picture what y equals x squared is in their mind, right? Okay, we found y equals x squared. Now we just take the derivative with respect to x, and we find dy dx. So now let's take the derivative. And I need to move this over just a tad to make it look slightly neater in my notes. So I'm going to say, what is d dx of this thing? And I say, oh, d dx, or dy dx now. The derivative of y with respect to x is what? With another quiet raised hand. Who have I not heard from yet today? Someone that has their fictional participation card. Yes, Andrea.
Yes.
What's the derivative of x squared?
2x.
There it is. Now this is useful, and we can box it like we found it, right? Boom, there it was, 2x. This is useful because I can say, if I'm, where am I on the coordinate plane? I'm going to choose like 7. What is the slope at 7? I plug in 7 and I say, oh, the slope is 14. That is helpful. That's useful to know. You can like have this as an applied problem to like if you're talking about, I don't know, a missile. I always get super violent when it talks about applied applications because that's typically historically where mathematics is used. But it's useful. I won't go too much into the violence of mathematics. Okay, so the problem is, what if it's really, really hard to convert this thing, this x equals t squared and y equals t to the power 4, what if it's really hard to convert that into y equals x squared, to convert it into Cartesian form? We need a different system that will work over and over again. And I'll give you guys kind of a reveal. It's really easy. There's a cool little shortcut that we can use, and I'll show you how it works. So dy dx, or dy dt is the same thing if I take its derivative. Did I write that correctly? Dy dt? Yes. So if I take the derivative, dy dt is the same thing as, hold on, I put it in my, yeah, there it is. Dy dt is the same thing as dy dx times dx dt. In terms of just the variables, you can see that some things will cancel out. If I look at the dx and dx, I can cross cancel, chunk, chunk, gone, and you can see that this is indeed dy dt. Hopefully you guys are digesting that. It is the same. Dx cancels out, this dy dt. Nothing has really changed that much. But now I can solve for dy dx. That's what I was trying to find. What is dy dx? Well, I'm going to divide both sides by dx dt. So this dx dt, I'm going to divide both sides by him or her. dy dx, or so dx dt, divide both sides by dx dt, divide by dx dt, and we're done. We have our formula. If I ever want to find dy dx, which is the thing we're trying to find, it is equal to dy dt divided by, I don't know why I wrote dx dx. It should be dx dt. I get so used to writing dx. That is my mistake. I should have let someone catch it, though, for the extra credit. My bad. If you want to write it again so it's more prominent, you can say dy dx is the same thing as dy dt all over dx dt. That's about right. X again. If you say it in words, it makes it a lot clearer. If I want to find the derivative, the main derivative that I'm really looking for, take the derivative of y divided by the derivative of x. And doesn't that kind of seem familiar? Y over x, isn't that kind of like slope? Delta y over delta x? Delta y over delta x? There's a lot of things in mathematics that are always going to be y over x, so this is just another one of those examples. And that's kind of the big reveal of this lesson. If I want to find dy dx, derivative of y divided by the derivative of x. Okay, let's see if we can start using that now. Why did I give all this room in the notes? I don't remember. Was I really going to do a ton of math? I guess I messed that up. Okay, well, let's go on to example number 1. Let's find the derivative of that thing. I have it in, or it's not in Cartesian yet, it's in parametric, and I can't really convert it to Cartesian that easily. I could. But let's do it now. So I'm going to take the derivative of y and then divide it by the derivative of x. Oh, I remember what that blank space was. We'll come back to it. How do I do this? Can someone help me? You're just using the formula that we had up above. Someone help me, please. Yes, Gio. So it's the derivative of y, and then divide that by the derivative of x. 4t third. That's the numerator. The denominator is? There it is. Chris, can you reduce this for us, please? Chris, you got this. 4 and 6. Greatest common factor. Divide. Go. If I had the fraction 4/6, it reduces to? You don't know? Okay. Chris, you can call on someone.
He says James.
Okay, go for James.
Oh my god, this is 2/3.
Yeah, so 2/3 is that function, or the number out front. And what about the powers? I have t and I have an invisible 1 down here, James. So it's going to be 2t to the power of 2. There it is. Box it. Final answer. That's it. And I might have jumped the gun because isn't that in form of, isn't that t? Shouldn't we have an x in there? So how could we get an x? It's already done. Let's divide both sides by 3 and check out what happens. T squared is x over 3. I'm trying to get an x, that's why I'm not manipulating the y at all. I want this in terms of x.
What about the plus 7?
Oh yeah, I could probably subtract the 7 too. I'm so sorry, guys. I have failed algebra 1. Let's subtract that 7 first. Arrow, log the extra credit in your mental extra credit tracker. See, Arrow is not bound by the gospel of Mr. Sindel.
Arrow, you want to give it a test? Oh, okay.
That actually might be a cool system.
If I could give it to people?
Yeah.
Can I be
Claire's
first?
been wanting to do that forever.
I know.
She has?
Yeah, she's always trying to give.
Did she ask me and I said no?
Yeah.
Then I'm gonna have to say no to be consistent. But that does sound like a good idea the more I think about it.
You have to tell Claire first. If you let Claire do it first.
All right, and then divide both sides by 3. Why are you isolating for t squared, Mr. Sindel? Good question. Someone else answer it.
Guys, look closely at the y equals t to the 4th. Isn't it similar to the first problem? No. What does it even mean?
I want someone to connect these 2 pieces right here. What do those circled pieces have in common? Please, someone. Please. I beg of you. Yes, James. They both have? There it is. They both have t squared, which means this t squared is this t squared. This t squared is x minus 7 over 3.
So which one's the answer?
So the answer, I do 2/3 still. And that t squared is no longer t squared, it's x minus 7 over 3. So our full answer, the one that we do actually box, is this. 2x minus 14 all over 9. So let's apply that to our same problem. I told you there was a blank space for a reason, and I finally remember what it was for. I want to solve the original problem that we were given. This thing right up here. Let's do that. What is dy dt? I want to apply this formula right here to this problem. Can someone plug it into the formula, please? Who have I not heard from? All right, so Gio's doing it for us. You said 4t to the power of 3 divided by 2t?
Yes.
Where'd you get those from again?
Derivative.
Yeah, we already did the derivatives, and they're right there. Chunk, chunk. Perfect. So we did the dy on the top, the dx on the bottom. All right, now someone simplify. Sego. 2t squared. Perfect. And again, that's not in the form that I want. It has a t instead of an x, so I need to get rid of that t. How do I get rid of that t?
You just put an X.
Well, there's t squared. There's t squared. T squared is x, right?
2x.
So I come back here and say, yes, this is equal to 2x. And hey, check it out. 2x was the answer.
Are we ever
2x is the answer.
the first way of doing or always we
If you can, then go for it. If you see an easy way to convert to Cartesian, do it, because that'll be the quickest path. This is the formula that's going to be taught because they're almost always going to be giving you on the AP calculus test a hard thing that you need to use the formula for.
Okay.
And you could say, hey, they match. Okay, that's the end of the notes. All right, so I'm trying something new. I want everyone right now to not only give me a fist of 5, but they're going to do something else after the lesson's done. So, how well do you think that you can take the derivative of parametric functions? I see a 5, a 3, a 3, a 3. Got you, Fiona. 4, 3. Chris is 3 and 3, and James is at a 3. Chris is at a 3. Okay. I also want you guys to, without writing down the summary, again, the summary is always for homework. What is the most important thing that you learned from today's lesson? You have to talk to at least one other person, if not 2. What is the most important thing from this lesson?